Spirometry is a method by which the volume of air we breathe in and we breathe out is measured. It's a method using a special instrument. We measure the amount of air, the volume of air we breathe in and out. The reason why volume of air we breathe in and out needs to be measured is because this volume changes during disease. If people suffer from respiratory illness, the volume of air, maximum volume of air, a sick patient, someone whose respiratory system is sick, decreases or changes. So spirometry, being a method of measuring respiratory volume, helps to diagnose diseases. And the results found during spirometry are best represented with a graph shown here. The vertical axis or the y-axis of this graph represents the volume of air we have in our lungs at any given moment, whereas the horizontal axis or the x-axis represents time. So the important part is the vertical axis. By the way, in a healthy or even sick person, our lungs are never empty. There is a certain amount of volume which is in our lungs even after we did maximum exhalation, or if we after we breathe out maximum volume of air, there will be some amount of air left in our lungs, and that amount of or that volume of air left in our lungs after maximum expiration or after maximum breathe out is known as residual volume and is represented by this part of this graph. So this is the minimum amount of air left in our lungs after we make maximum expiration. So during normal respiration, a healthy adult breathes in and out approximately half a liter or 500 milliliters. So this narrow bar or this part of the spirometry graph represents the amount of air we breathe in and out while we are at rest and quietly breathing, and which is normally 500 ml. So what does the rest of the graph show? Let's start here. We have been breathing in and then we breathe out and then we breathe in normally. If we try to breathe more, applying effort after we breathing the normal amount we breathe, for example, we breathed in, follow my cursor, we breathed out quietly without effort, and then we breathed out, we breathed in without effort, we breathed out without effort, and then we breathed in without effort. If we apply effort and further breathe in, we can breathe this much, which is around 3 liter or 3000 milliliter from here to here. So this additional amount of air which we can breathe in with effort after breathing the normal amount is known as inspiratory reserve volume, and it is shown to be around 3 liter and 100 ml. So I am defining inspiratory reserve volume. It is, as the name itself tells you, it is the amount of air we can breathe in after normal inhalation with additional effort. So when we exhale back, we can release that additional air we breathed in. Then we also breathe out that normal one. After breathing in a normal amount of air, after breathing out a normal amount of air, the normal amount is 500 ml. I said this part is the amount of air we breathe in and out while breathing normally, quietly at rest. So we are here now, and we breathed out. As we go down, that is a breathe out. If we apply effort, we can breathe out additional air, which is expiratory reserve volume. It is shown as being 1.2 liter or 1200 ml. You can find that volume by decreasing this from this. That's how they found it. So this additional amount of air which we can breathe out after normal exhalation is known as expiratory reserve volume. The word reserve makes sense, right? It's reserve amount of volume or reserve volume of air we can breathe out with additional effort. As I explained earlier when I was talking about mechanism of breathing, in order to breathe out this additional volume of air, we're gonna need to use our internal intercostal muscles and abdominal muscles, right? That's what expiratory reserve volume is. And we can breathe out that and go back to normal. So the volumes I introduced to you so far are residual volume left in our lungs after maximum exhalation, and tidal volume, the amount of air we breathe in and out during normal, calm, quiet, at rest respiration. Additional volume of air we can inhale with effort, that is inspiratory reserve volume. And then the additional volume of air we can breathe out, expiratory reserve volume. By the way, during spirometry, when we measure the amount of air we breathe in and out, what we can measure is what we breathe out, because patient is asked to breathe into the machine, into the spirometer machine, and that machine measures how much air was blown into the machine. But patients are not asked to breathe from the machine into themselves. So what we actually measure is what we breathe out. So then how do we find out how much we breathed in? To find out how much we breathe in, we use formulas. There are formulas which can be used to calculate the amount of air we breathe in, because we do not breathe from the machine to avoid breathing in some dirt which might be in the machine. But we breathe into the machine when we do spirometry. We do not breathe in from the machine, but we breathe into the machine, which means we exhale into the machine. We breathe out into the machine, but we don't breathe from the machine. So the machine can measure the air we breathe out or we breathe into the machine. So how do we find out, for example, inspiratory reserve volume? How do we find out the amount of air we breathed in? Using mathematical formulas. And here are some of the formulas here. By the way, before I go to the formulas, let me talk about vital capacity. As you can see here, vital capacity is inspiratory reserve volume, tidal volume, and an inspiratory volume together. This is known as vital capacity because it is the amount of air which can be taken into the lung and taken out of the lung. This one is never taken out, never breathed out. So this is one more volume I wanted to introduce to you. So when we come to the formulas which are here, look at this formula. Vital capacity, I told you, is tidal volume plus inspiratory reserve volume plus expiratory reserve volume. You need to get used to these abbreviations also. Total lung capacity is including the residual volume which is left in the lungs after maximum exhalation. Tidal volume, the normal amount of air we breathe in and out during quiet, restful breathing. Inspiratory reserve volume, expiratory reserve volume. All of these added, they give us total lung capacity, meaning the total amount of air which can be contained in our lungs after maximum inhalation. You already know total lung capacity, which can, residual volume, which can be calculated from total lung capacity minus vital capacity. Practically, if we replace this vital capacity with these volumes, you can come up with another formula. So these are the formulas used to calculate the air we breathe in after calculating
We measure
the air we breathed out.